Good morning, dear students. I am Mrs. Priyanka Dikshit, working as Senior Assistant Professor in the School of Pharmacy, BBD University, Lucknow. Today we are going to study about the topic acids and bases. Let's start the topic. Acids and bases. There are four main theories regarding the definition of acids and bases. These are traditional theory or traditional concept, Arrhenius theory, Bronsted and Lowry theory, and Lewis theory. Traditional theory regarding the definition or concept of acid. According to this theory, acids are the substances which are converting blue litmus paper into red. They are having pH lesser than 7. They are having sour taste and they are reacting with bases to form salts and water. Example, hydrochloric acid acts as an acid because it reacts with base NaOH to form salt of NaCl and water. Traditional theory regarding the concept or definition of base. According to this theory, bases are the compounds or substances which converts red litmus paper to blue. They are having pH greater than 7. They are having a bitter taste and they react with acids to form salt and water. For example, sodium hydroxide reacts with HCl acid to form salt of NaCl along with water, so it is a base. Arrhenius theory. The Swedish chemist Svante Arrhenius proposed the first definition of acids and bases. According to Arrhenius' concept, acids are the substances which are capable of providing H plus ions or protons when dissolved in water, and bases are the compounds that are capable of providing hydroxyl or hydroxide ions in aqueous solution. For example, hydrochloric acid in water undergoes dissociation to produce H plus ion and Cl minus ion. Since hydrochloric acid in aqueous solution is giving H plus ion, so it is an acid as per Arrhenius concept. Similarly, NaOH when dissolved in water if gives hydroxyl ions along with Na plus ions. Since NaOH is giving OH or hydroxyl ions in the aqueous solution, it is a base as per Arrhenius concept. From the reaction, it will be more clear. Here, HCl ion in aqueous solution provides H plus ion and Cl minus ion, so it is an acid. Or HCl reacts with water to provide hydronium ion along with chloride ion, so it is an acid as per the Arrhenius concept. Another example for base is NaOH. When this base NaOH is reacting with water, it is providing Na plus and OH minus ions. So it acts as a base since it is giving hydroxyl ions in the aqueous solution. According to Arrhenius theory, the neutralization process or reaction can be represented by a reaction involving combination of acid and base to form salt and water. For example, it is a reaction involving combination of H plus ion and OH minus ion to form water, or it is a combination of reaction where sodium hydroxide reacts with HCl to form NaCl and water. Limitations of Arrhenius theory. The Arrhenius theory is applicable only in aqueous solution. For example, according to the theory, HCl is an acid in the aqueous solution but not in benzene, even though it donates H plus ion to the benzene. Also, under the Arrhenius definition, the solution of sodium amide in liquid ammonia is not alkaline, even though amide ion deprotonates the ammonia. Basicity of ammonia is not explained in Arrhenius concept. Acidity of boron trifluoride and aluminum trichloride is also not explained in Arrhenius concept. Acidity of oxides of p block element is not explained. Basicity of oxides of S block element is also not explained. Neutralization without the absence of solvent is not explained. Bronsted-Lowry concept. Bronsted-Lowry concept emerged in the year 1923, and this concept was given by the Danish chemist Johannes Nicholas Bronsted and the English chemist Thomas Martin Lowry. They proposed the theory as follows. According to Bronsted-Lowry concept, an acid is any compound, molecular or ionic, that can donate a proton to any other compound which may also be molecular or ionic, whereas a base is any compound that can accept a proton from any other compound. The reaction is shown as follows. Here, HCl reacts with water to form hydronium ion and Cl- ion. In this reaction, HCl acts as an acid because it is giving or donating its proton to the water to form hydronium ion and chloride ion, whereas water here acts as a base because it is accepting a proton from the HCl to form hydronium ion and chloride ion. Good morning, dear students. I am Mrs. Priyanka Dikshit, working as Senior Assistant Professor in the School of Pharmacy, BBD University, Lucknow. Today we are going to study about the topic acids and bases. Let's start the topic. Amphoteric. Amphoteric compounds are any compounds that can donate as well as can accept a proton. They are also known as amphiprotic compounds. Conjugate base. Any compound or any species that is formed after an acid donates its H plus ion is called conjugate base. Conjugate acid. Any species or any compound that is formed after a base accepts a H plus ion is called conjugate acid. Limitations of Bronsted-Lowry concept. According to this concept, every arrhenius acid is Bronsted acid, but every arrhenius base is not a Bronsted base. For example, NaOH is arrhenius base because it gives OH minus ions in aqueous solution, but it is not a Bronsted base because it cannot accept a proton in aqueous solution. The protonic definition cannot be used to explain the reactions occurring in non-protonic solvents such as phosgene or CoCl2 sulfur dioxide and dinitrogen tetraoxide, etc. Substances like boron trifluoride, aluminum trichloride, etc. do not have any hydrogen and hence cannot give a proton, but they are known to behave as acids. Lewis theory. This theory explains the acid-base phenomena in terms of the acid and base along with the formation of a coordinate bond. According to Lewis, in 1923, an acid may be defined as any species, molecular, radical or ion that can accept an electron pair to form a coordinate bond, whereas a base may be defined as any species that can donate an electron pair to form a coordinate bond. Thus, in Lewis system, an acid is an electron pair acceptor and base is an electron pair donor. Examples of Lewis acids are H plus ion, ammonium ion, Na plus ion, K plus ion, Cu2 plus ion and Al3 plus ion, etc. whereas examples of Lewis bases are ammonia, water, hydroxide ion, chloride ion, cyanide ion, etc. Limitations of Lewis concept. The Lewis concept may or may not include the general idea of all coordination reactions and compounds. It couldn't explain the behavior of protonic acids like hydrochloric acid and sulfuric acid, which do not form coordination compounds with bases, hence were not regarded as acids. Lewis concept do not explain the relative strengths of acids and bases. This concept was not applied to acid-base reactions. It couldn't explain the energy released during covalent bond formation. That's all about the topic acids and bases. Thank you, dear students.